Okay, so as mentioned, I am Ruben Pieters, and I work at Square, where we develop tools for to help developers with mobile application security. And I'll be talking about a kind of related topic, which is Android frameworks and reverse engineering. So recently, a friend of mine was had this kind of weird idea for an app. He said, like, okay, normally an app is developed like we have a developer, he consumes coffee and then creates an app. What if instead we have like an app consume coffee and create more apps? So what the UI would kind of look like was something like this. So we have an app, we click on a button and the app consumes coffee, and then we send it to the server for verification and apps are created. And so, of course, the only technical difficulty here is like, which Android framework should this be developed in? Like he definitely had a high idea of the app, and he thought like, what if people are trying to tamper with it and try to modify it? Like, what if they try to create coffee out of thin air or apps out of thin air? So we're going to have a kind of a look at apps, this kind of simple sample app, and developed in different Android frameworks, and have a look at how we can reverse engineer them and what the impact of the framework actually is. So the general approach that we're kind of going to take for each framework is we're going to look inside the APK, like the actual format that runs on your phone. We're going to explore it a little bit to see what's going on in there. And then we're going to try and do some modifications, and then also try some alternative configurations to see how much that actually impacts the modifications of the app. So to zoom in a little bit more on that. So we have our original source code that gets bundled into an APK and eventually runs on the phone. Then, of course, this APK contains in some form the compiled source code, depending on the framework, will be in different formats. But that's kind of the thing that we're interested in. There's also kind of resources and assets, but of course, the main thing that we're interested in modifying right now is the source code. And there are kind of two main ways of doing modifications. One of them is patching or repackaging the APK, which is kind of creating an entirely new APK based on the old one, but doing some modifications on it. So when we run this new APK, it will have different behavior from before. And another thing is kind of dynamically modifying or hooking the app, where we run the original APK, and then while it's executing methods, we're going to say in certain specific points, like, okay, instead of executing this method 1, actually do this patched method 1 instead, and then we can modify the behavior of the original APK while it's actually running. And what kind of modifications can we do? Like, we can really do all kinds of things as long as we are able to find how to do it. So in this case, we're going to look at like changing the amount of coffees that are being consumed, or changing the amount of apps that are being created. And so these kind of principles of reverse engineering and modifying the applications are kind of applicable to all kinds of applications. It's like, I'm going to show them on this simple application here, but the basic principle doesn't really change that much if you're changing an actual released application, like a banking app or a gaming app or something else. And then the alternative configurations. So typically frameworks will have some options to like do some shrinking or minifying or obfuscation, depending on how it's named. So if that's relevant, we're also going to enable that, and then have a look at how much it actually changes, on like how much difference does it make on actually making modifications inside the application. So the main goal is here is to kind of give you sort of a showcase of like what the techniques are. I'm not gonna like go into all the deepest details, like on actual released applications. Some of these things are going to be a bit more difficult, of course. But it's kind of an entry point for you to sort of see like what these techniques can do, what to evaluate for you, like whether these are potentially impactful for you as an app developer, and potentially also read more resources online and have a better sort of entry point into what these resources are telling you. So then let's have a look at the first framework, so the kind of base XML Android version of the app. So when we look at the APK here, if we look at the broad overview, we'll see that we have this classes.txt file, and we have some resources and resource files. And in this text file is actually where the main code is located. So what has happened is that we have our Kotlin code. In this case, the app was created in Kotlin. It was in the Kotlin compiler compiled the Kotlin code to class files, and then D8 will actually compile these class files into DEX files. And then these DEX files are the thing that the Android runtime understands and is the actual code that is being run on your phone. So how can we look what is inside these DEX files? So one tool that we can use that is widely used actually is JDEX, and this will actually decompile these DEX files into kind of readable Java format. And then when we do that on our simple application, the UI will kind of look like this. But in my slides, I will just kind of highlight the actual important pieces. So when we actually look inside the main activity, we'll see this increment coffees method. And then the input, or it takes an integer value as input, and then it returns that integer value +1. So then if you look around a little bit where it's used in the main activity, you might see, okay, this is actually the place where we click the button where the coffees are being incremented. And then what we're going to do is we're going to apply one of the techniques I mentioned. So we're going to do hooking with a tool called Frida. So Frida is basically a kind of, I would say, more generic hooking framework, but it also has specific APIs, for example, the Java API, to work with Android applications. So that's what we are going to use right now. And JDEX, actually, one of the more recent versions, have this kind of neat thing where if you right-click a method, you can copy a Frida snippet and already have kind of a pre-built Frida snippet for you to start from, basically. So let's have a look. We're going to modify it a little bit, and then let's have a look at what's going on there. So the first statement is just that we're using the Java API, and then we will look for the main activity, basically. Then we will look for the increment coffees method on this main activity, and we'll modify its implementation. The modified implementation is kind of, we wrap it with logging. So we log what's coming in, we log what's going out, and then inside we call the original implementation. And then in this modified implementation, we'll also modify the return value. So when we call the original implementation, we'll increment the value by 1. And then in this modified implementation, we'll actually increase that by another 99, which means that in total, the function will have increased by 100, or the input value will have increased by 100 when we return it. And then kind of instead of live demo, I have these videos to show you how that looks like. So in this case, I'm going to start up the original app, show you that the copies are incremented by 1 each time. And then when we start the app with the Frida script attached, and I click the button, then the consumed copies are increased by 100. So we've modified the behavior of the application. Then let's have a look at the R8 version. So when we basically enable R8, it will do some shrinking. It will do some simple name obfuscation. So when we look at the classes of DEX, we can definitely see that the size of this DEX file has decreased by quite a bit, so quite significantly. But kind of the basic compiling process is roughly the same. R8 is really kind of a different operating mode of D8, which will do some different steps. So additionally, it will do some optimizations. It would do name shrinking, and then also do the text compilation, of course. And then when we look at the source code, we can already, or in JDEX, when we look at the packages, we'll immediately see a lot of the packages have shortened names. They have A0, and so on. And then when we look at the codes, we'll also see that some classes have shorter names, the variable names, the fields, the methods, and so on. The names have all been shortened. Okay, so now to get our grip and to understand what's going on, it's a little bit more difficult, but the actual content inside the methods is, we'll see that later, is still going to be, not a lot of the actual contents will be touched in the code content. But it will be touched a little bit, so because of optimizations, for example. So if you're going to look for something that looks like the increment coffees method, which increases its input value by 1, we're not going to find that because it has been inlined into another method. So that's one of the optimizations that R8 has done. So if we try our original script, it's obviously not going to work because the name of the method would have been it would have been renamed. But even if we try to find that method, we're not going to be able to actually find something that looks like that. But so when we look around a little bit further, we see that some things haven't changed names. So in this case, we have these resource identifiers that haven't changed. And when we look at what this function actually does, it kind of sets sort of a value that represents the amount of coffees, and then it sets the text of the button to tell you how many coffees you have consumed. So in this case, we are okay, this is kind of the method that updates the amount of coffees we actually have internally inside our application. So we can hook this function instead, again with another Frida snippet. In this case, we're going to modify the input of what's going in. So the other pieces are kind of the same as before, just mentioning a different method. And in this case, we're going to modify the input. So basically, each time we update the state of the app, it's going to add 99 to it instead. So also so here it's going to load up the original script before to show that it doesn't work. And then when we click the app, it has its original behavior. And then when we load up the other script, the app is going to start with 99 because initially it calls the update function once with 0. So it starts at 99, and then each time we click the button, it increases it by 100. So now we also have modified the behavior of the app. Okay, so modifying this behavior of sort of basic or XML Android apps without any kind of special framework is not that difficult. Like the Frida APIs, Frida is quite a nice and mature tool to use, so the Java APIs work quite well. And doing this is not too complicated. So let's have a look at something else, Jetpack Compose. So in Jetpack Compose, when we look at the APK, it doesn't look that much different. We're only going to be looking at the R8 version this time. So if we would compare it with D8, we again see that the text file has been shrunk by quite a bit. And so in this case, when we from this broad overview, it doesn't look that different. But when we look at the actual DEX code or the decompiled code, it's going to look quite a bit different, even compared to the source code. That's because there's in addition to the normal Kotlin compiler, we also have this Jetpack Compose DSL that's being transformed in some different ways. We also have these anonymous functions. We have more top-level definitions, which means that R8 can actually kind of shuffle and optimize the code around quite a bit more. There's also some optimizations that are kind of tweaked to deal with code that occurs a lot in these Jetpack Compose applications. So this is one example of that thing that you might encounter. And so if I in my sample application look for a string that might be interesting, like coffees consumed, for example, we're going to see this function u. It has an object output type, it has some object input types, and then we have the switch on i3 and so on. And eventually, in one of the cases, we have this coffees consumed string. So this isn't code that was literally part of my original app. So this is basically kind of the result of an optimization called lambda groups, where R8 is going to kind of merge together different anonymous functions together. And I mean, it's an optimization, but it does, make hooking this function a little bit more difficult. We need to do a few additional steps to kind of see what's going in, see what's coming out. But in this case, I'm not going to look or do that specifically. I'm kind of a lazy reverse engineer, so I'm going to try and find an even easier approach. So I'm going to leave this as an exercise for the reader/watcher. So as I mentioned, I'm going to try and find a more an easier approach. So instead of like, remember that the application will be contacting a server, so we might look for other kind of strings that could be interesting, like looking at like when we construct a new URL, or when, like for example, HTTPS or something, like we could search for .com or something else. In this case, when we look for new URL, for example, we find this piece of code, which we still need to kind of squint a bit to see what's going on, because some of the identifiers have been renamed, but we can still see that kind of when we create the output stream, there's a certain variable that goes into or gets converted into bytes and then goes into the actual output stream that goes out to the server. And so this is like a neat little packaged function that we can actually hook and modify its behavior to have an easier approach of modifying what's going on in the app. So the Frida snippet is kind of quite similar as before. We just need to look for our class, we need to look for our method. And then because the method will look up a field inside the class where we're invoking the method on. So instead of like looking at its inputs or something, we have to modify that field to actually modify its behavior. And so when we look at the setup here, so it's kind of similar as before. We have we started the app with the Frida script, and now instead of clicking on the coffees consumed button, we have the apps created that changes its value by 100 this time. So again, we have modified the application behavior. So in this case, it was like a little bit more difficult. Like the decompiled codes was a bit more, I guess, a bit more surprising that than what we might have expected. It didn't map as well to original source code because of the DSL, because of the optimizations, but still we could use these kind of easy to use Frida APIs to modify what's actually going on inside the app. And then next, let's have a look at React Native. So in React Native, we kind of have, like, because the recent versions use the Hermes engine instead of JavaScript engine, I'm going to sort of go over both because the JavaScript story is still kind of interesting for other frameworks that work with JavaScript still. So when we look at our the APK, in this case, we're going to see something a little bit different. Now we have kind of a bigger lib folder where native libraries reside. So that's a bit bigger than the DEX files. And now also the impact of the RH shrinking is a bit less than before, or quite a bit less than before, because a lot of the main code is now in the lib folder and also in the assist folder, which we'll see. So what's going on here? So we have our JavaScript files. That's like the app code, basically. And all of these get bundled into the index.android.bundle. And then this bundle will be run inside the JavaScript core engine. And this engine is actually packaged inside the application. This is the libjsc and libjsc executor.so files. And then this engine will actually communicate via a bridge with the Android native components to receive events, for example, and show things on the screen, so it interacts in that way. And here we're actually going to patch or repackage the APK, and we're going to use APK tool for that as a sort of, in this case, it's going to be like more of a fancy zip/unzip. But APK tool can also be useful because it disassembles DEX code to Smalley, which is kind of a more readable format of DEX code. It can also disassemble some of the resource files, resources, and so on. But in this case, we're mostly going to use it as a fancy zip/unzip. So when we kind of use the decompile version or option of APK tool, we have kind of an unpackaged APK. And then we can just search for strings. And when we do that with coffees consumed, for example, we'll see that we have a hit in our index.android.bundle file, which contains all the bundled JavaScript, which is just packaged inside the application in plain text. So, and in this context, we have like a button this function that's being called, and then some parameters being increased by 1. So then we might think like, okay, yes, that's the amount of coffees that's being increased, so we can increase it by 100. And then when we kind of repackage the APK and run it, we'll have our modified application. So I don't have a video for this one. We're gonna look at the video afterwards of the Hermes one, which is a bit similar with a few additional steps. But like we can use these options to or use these commands to repackage our application and then run the modified APK. So then let's have a look at the Hermes version, where like if I use a version of React Native where I have to enable it explicitly, I can do that and then create my APK. But in later version, this is kind of the default setting. So when we look at the compiled APK, it's gonna look quite similar. It's on this broad overview, it doesn't look too different. And in this overview, it also isn't that much different. So instead of the bundle being JavaScript, it's now Hermes bytecode. And then we, of course, have a different engine to actually understand this Hermes bytecode, which is also packaged inside the application. When we search for the coffees consumed string now, we'll see that there's a binary file that matches. So it's no longer kind of visible in plain text. And then when we look at what kind of file this actually is, we'll see that it's basically Hermes bytecode. And a tool that we can use to kind of see what's going on there is HPC tool, which is basically a tool someone made to disassemble and assemble this Hermes bytecode. So that looks kind of something like this. And then, so we create basically kind of a text file with all the Hermes bytecode instructions of all the code that's going on in there. So then in this file with the disassembled code, we can now look where the string is actually located and where it's used. So we can search for coffees consumed. And then later on, we see that a few instructions later, we see that an on-press closure is being created with this identifier 4001. So we can have a look there, what's going on in there. And then we see that a constant is being loaded 1, and then it's later being added and returned. So here we can it's a plain text file, so we can just modify it and then assemble it again to modify the code. And then we can repackage the application and run it, and then we'll have a look at what this looks like. I'll just increase the speed a little bit on this one. So first I basically run the original application. We see that it's increasing it by 1 each time. Then we will decompile the original application. Then we'll disassemble the Hermes bytecode, have a look at the bytecode, do the steps like search for the string. Then we'll look at the identifier of the closure. Then we'll modify the behavior inside the closure, or basically this one register. And then we'll assemble the code again, package the application again. Takes a little bit of time. Then we have to zip a line and sign it. And then when we run this new modified application, we'll see that it has the modified behavior. So now we've modified the behavior by patching or repackaging the APK. So this is already definitely like a step more difficult, right? Definitely the Hermes version, where we had to use some more specialized tools to actually deal with Hermes bytecode. This will, on like real applications, this will be a bit more difficult because we can't explore as easily as with something like JDEC. So this is definitely a step more difficult. And then next, let's have a look at Flutter. So Flutter is kind of, this broad overview is kind of more similar to React Native, where we have this lib folder. The classes.txt file is again quite small, and the impact of arrays is not it's noticeable, but not as impactful as before. And the resources and resource files, there are not that many because Flutter doesn't really use that much of the kind of native, the Android stuff, which we'll see later. So what's going on here is that our application code is implemented with Dart code. That is being compiled by the Dart compiler into libapp.so, which is part of your APK. And then the Flutter engine is also part of the APK, which is inside the libflutter.so. And then when we look at the dependencies of the Flutter engine, we'll see that it is interacting with these graphics libraries. And so the Flutter engine kind of really works more like a kind of game engine, in that it directly interacts with these graphics libraries and doesn't really interact as much with the native Android components. But so the interesting thing with this libflutter is that basically we can we can add logging to this Flutter engine, and then we can compile the Flutter engine again, and then put it inside our APK to, for example, have a better understanding of what's actually going on in this libapp.so, because the libapp.so is kind of a format that is a bit more volatile. It's kind of a Dart snapshot format, so it's not as easily to reverse it statically. And reflutter kind of is a project by someone created to make this process kind of easier. There are several pre-built modified Flutter engines, and then the reflutter kind of command line utility will repackage your APK and put this modified Flutter engine inside of it. So when we actually run our modified application with this modified Flutter engine, we'll have this dum.dart file, which contains kind of offsets for the functions inside of our of the Flutter application. So in this case, we're interested in the increment coffees function, and then we can see that it has this offset on a specific symbol. And so we can use this information again with Frida. So now we have to use the sort of, I guess, more normal or the native Frida API instead of the Java API, where we'll get a base address on this specific symbol in libapp.so. We'll add a specific offset to it, the offset of the function that we're interested in. And then this is kind of similar as what we did before with the other increment coffees function in the base Android version. We're going to kind of read the input. In this case, we're going to read the input of the first input value, and then we're going to modify the output. And like after leaving the function, we're going to add 99 to the output value. Again, I don't have a video for this one. We're going to first do another step. So we're going to also use the -- obfuscate flag. So maybe just to clarify, so if we would run this function with the original APK, then we would have the modified behavior. So, but first let's have a look at also the -- obfuscate option. So what this option does is kind of somewhat similar to enabling array in the base Android chapter that we saw. So when it will basically do name obfuscation, so it will shorten all of the names. It doesn't do as much optimization or stuff like that, but it will mainly do this name obfuscation. So the overview of the application doesn't really change that much. Instead, but when we look at the dum.dart file, we'll see that a lot of the identifiers have become a lot shorter, right? So and now we can't find like the increment coffees function by name. And also to kind of show that what's going on is really only changing the names, and for example doesn't modify any strings. We can still kind of use the strings command line utility to search for in the -- obfuscate version of the SO file that's inside the app. We can still kind of search for strings that are inside of there. But so the thing that I wanted to do here is I'm going to show this still in a few minutes, but on this dum.dart file, we cannot use the name. So instead, I just wanted to kind of dynamically find out which offset I need, which represents the increment coffees function. But I kind of find out that the dump.dart file was incomplete. I'm not entirely sure why that is. Maybe I wasn't using the correct versions or something like that. But to actually do the thing properly, I had to use a bit more heavyweight tool. So I had to use IDA Pro to get the offsets. So this isn't a free tool. This is a paid software, basically. So, but I kind of need one small thing, is just this utility function to get a list of all the function offsets, basically. So that's kind of the thing that I wanted from the other, from the reflutter version of the APK that wasn't working. So when I do that, I just get a list of all the offsets that I need, and then we basically want to find out dynamically which offsets actually corresponds to the function I'm interested in. So a very simple trick, but if it works, it works. So it's basically to hook all the offsets with Frida and kind of add logging or some other kind of side effect to kind of figure out when you're using the app, what functions you're actually interested in. So when I, for example, click the button, I'll see, okay, these are actually the offsets that are being called. And then I can also look at the input that is coming into the function to see, like, okay, for example, the first time the function is called, it should be called with 0. The second time, it should be called with 1. It's kind of like a poor man's cheat engine if you've ever used that desktop application. But this way, we can kind of dynamically find out which offsets actually we want to modify. And then we can kind of use the same script as before. That doesn't change much to kind of modify the behavior of the application. So this is then kind of what the script looks like. There's some slight modification here at the top, because now the offset is, because I got it with IDA Pro, is based off of the start of the base address of libapp.so instead of the specific symbol. But other than that, the script is kind of the same as before. We add our specific offsets. And then this is basically unchanged. Okay, so let's have a look at this video. So this is going to show kind of the whole process, starting from when we have the offsets. So when I then I click the button, I have started the Frida script, which first kind of logs all the things that we're calling and its input. So first, we see all the offsets that are being called, and then I have this utility function to show a function that is being called once with input value 0. So this kind of narrows it down already a little bit. And then when you click it again, I'm going to search for functions that have been called twice. And then we see here that there is one function that has been called with input value 0 and 1. So that gives me the offset of the function that I'm interested in, which corresponds to the increment copies function. And then we're going to use that offset in the other script, the other Frida script. So we'll paste it in there. And then when we call the, or attach this Frida script then we'll see that we have modified the behavior of the application. So now it's increasing the values by 100 each time. So this was already like quite a step more difficult, right? So we had to kind of use also more specialized tools. We had to use like the more native or the native API inside of Frida. So definitely a step more difficult. But the thing is that like I can show you kind of these examples today of like things that are available online today. But these things can change quite quickly. Like, for example, if someone tomorrow comes out with a Flutter Frida API, it can become quite as easy as it was just on the kind of XML Android version. So like I can show you kind of tools or techniques that exist today, but people still, like, as frameworks become more and more popular, like more and more of these tools get created. And kind of one kind of takeaway that I want to also give here is to kind of not rely only on your framework for security, in the sense that you can definitely use R8, you can use this obfuscate option, like these options work well, but you still should also kind of consider what it actually stops and what it actually does, right? So what kind of things are possible and what kind of things these tools actually do, and whether that is relevant for you or not. So I think it definitely helps to at least be aware of like what kind of reversing techniques are out there to kind of make an assessment on whether this is relevant for your application. But other than that, I also hoped you kind of enjoyed some kind of introduction to these reverse engineering tools. I would definitely recommend you to check out Frida if you haven't before. It's quite a mature tool and it's quite a lot of fun to play around with Android apps and just see what things you can figure out. It's also actually kind of a very neat debugging tool to sort of, if you really need to kind of on a more lower level, need to kind of figure out what kind of things are going on. So it can also be a helpful tool for you in like actual debugging during app development. Okay, so that was my presentation. And I will thank you for the attention.
Sweet. Thank you very much, Ruben. I think what we're going to do is if anybody has questions, we'll give you about a minute or two to write them as a comment on YouTube. And then Ruben can read them. Yeah. So I'm curious, Ruben, how do you get started as a compiler engineer? I don't feel like I've seen that role ever.
Well, I guess there's not really like kind of one way to get started. So I have actually a background in, so I have a PhD in basically functional DSLs for functional programming. So that's kind of my way into that. But I have always been interested in kind of the more lower level things of how, you know, the compilation process works, how these tools actually work behind the scenes, like the tools that we always use for our app development or just general programming development, like what's going on behind the scenes there. So I guess for me, it's definitely like it started from kind of an interest in these kinds of tools. And then I got into it that way.
Interesting. And like, were you at Guard Square when you chose to like perform as a compiler engineer, or is this something you've been doing for longer than that?
Yeah, so like so when I applied to Guard Square, I was basically looking for jobs related to compiler engineering jobs or compiler related jobs. So because during my PhD, I did did work related to domain specific languages and kind of also related to some compilation work there. So I was like, at that point when I joined Guard Square, I was already had some experience or related experience to that.
Interesting. It's a cool background. I feel like we don't.
So I think maybe one interesting thing is that I see also in like Android conferences is like the Kotlin part of the Kotlin compilation, and for example with Jetpack Compose, which also has like these plugins to specifically support what's going on there. So I guess if like specifically Android developers are kind of, or if someone is an Android developer and interested in more of these things that are related to what they are doing, I think that would be an interesting point to like look at what's going on in there. Because like when originally like the Java compiler still does some things, of course, but it doesn't do as much as other compilers. But definitely like the Kotlin compiler and these Kotlin plugins, like they already do quite a bit more that are interesting and potentially also relevant to understand. Like sometimes it just can help you in understanding why certain things are behaving weirdly or like are being slow or something like that.
Interesting. Well, I feel like this is also a good time. This pause is good because we have two questions. First from Sutansu. I've displayed it on the screen, so hopefully you can read that as well, Ruben.
Yeah. Yeah, I'll have to, because I'm sharing my entire screen. What do you mean share on the screen?
Oh, well, I can read it to you if you'd like.
Oh yeah, maybe that's easier. Yeah.
Yeah, it says this was a really insightful presentation. What would you suggest to get into security or compilers, and specifically like resources for getting into it?
Yeah. So, yeah, because like security and compilers are like a really broad topic. I don't have a kind of a specific one thing that you should like know. I think, as I mentioned, I think a good starting point is sort of things that are related to what you are doing already right now. Like if you, for example, use Jetpack Compose, like to try and see like what's actually going on when you are building your application, or if you're using another framework, like actually trying to understand what's actually going on, trying to find resources related to that. And security is kind of in a similar way. Like security has a lot of broad aspects. So maybe you are interested in reverse engineering, and then uh, like this some kind of reverse engineering tools related to you can find lots of resources online depending on kind of like what specific thing you are interested in.
Okay. We have another question from Mahmoud. What is the first vulnerability to look after for a more secure app, especially with sensitive local data?
Yeah, so um, the first I would say the first thing to look at is just trying to ensure that you're not, if you're storing local data, that it's kind of stored in a way that isn't just readable in plain text. So like being aware of like if you are using, for example, APIs of the Android framework, how what those things actually do and how those are stored on the device, and being aware of whether those are stored on plain text or not. So there's also quite some APIs that the Android framework provides you for more sensitive data. Like be aware of like what those APIs are, and then know when to use them properly. So I think that I would be my suggestion of like the first step of storing sensitive data is making sure that it's stored in the proper way. But then also sometimes what I also see is that sometimes data is being stored in somewhere, even if it's like not in plain text, like in encrypted form, when it shouldn't really be part of the application. Like sometimes certain sensitive debugging information or something, for example, like this debugging information can be useful when you actually have a problem with your application. But I think you should also be aware that maybe you shouldn't be always logging all the debugging information and storing it somewhere. Like so sometimes just that's kind of the safest thing, is like not having the information there if it's not needed is really the best way, but you need to evaluate whether or not like that's acceptable to you or not. Or like, I mean, sometimes it does need to be there, of course, like in many cases, but sometimes it doesn't have to be there. So then you can question whether it should actually be stored somewhere that's visible, or whether it should not be part of the application at all in its release form.
Sweet. And that concludes the questions. In which case, I think we're good to close out. The next talk will start in 20 minutes, about touch under that. Ruben, thank you so much for this wonderful talk.
Yeah, thank you for having me.
Take care. Bye, guys.
Yeah, all right.